All right, so today's presentation will be on global unique identifiers, or GUIDs, in the system. Just a quick overview on them, some information about them, how to make them, how we can compare them, between each other or other values, and some advantages and disadvantages of them. So GUID is a global unique ID. It's got a whole lot of values, so the odds of two running into each other or matching, although it's not impossible, it's pretty rare. They have happened with people. It's a unique 16-byte number, so it's a 36-character long string. And with SQL Server, you can auto-generate them in columns with like an identity value as an auto-incrementing number or timestamp. It's thrown on there. So creating them on the fly. How are they made? So we can select new ID and get a GUID out of that. You can take a string and convert that to a GUID and store it in a GUID variable or in a GUID database. So using the convert from string, you could actually generate it offline or manually cobble it together and put that into a GUID or a unique identifier data type column in the database. You can also auto-generate them. So in this little sample here, we have an auto GUID column. The data type is unique identifier, and we default to new ID. So that will generate a GUID like the one above for every time you insert a row number on there. So there's new ID, like the function, and that's a random 16-byte identifier. And then there's also new sequential ID. And the way this runs is you can see it's similar in each of the groups except for the first one. So it's still random, but it's a little bit more sequential. It's faster on inserts since it's a default when you insert into a table. There has to be a default on a column when you insert into a table. It is faster than new ID, but you still get all the bad disadvantages that come along with it, which we'll cover later. Comparison options, and for comparison operations and non-comparison operations, you can use it with equals, not equals, less than, greater than, which I guess you could use on sequential GUIDs, but not very performant. You could use like to search in the middle or anywhere of a GUID. You could have between, and you can also use is null and is not null, but you can't use any arithmetic operators like addition, subtraction, multiplication, or division, or modulus with them. Funny little thing here, when you do an order by on a GUID, it does not order alphanumerically from the very beginning. If you look at this last section here, you can see a GUID is 5 sections of this one, this one, this one, this one, this one. It orders by the last section. So you see here 0AA, 0B9, 17C, 1E4, 5BB, 940. And we'll look at it more in the demo. Just an interesting gotcha with GUIDs.
So when you do a between, does it do the whole thing numerically? That's kind of weird.
All right, so now I'll just go over some demos for these things. So select new ID. Pretty quick little thing here. Select new ID. You can run it over and over again, and you get a new GUID every single time. If you want to use that or fill a variable with a new ID, you can just declare your variable name, data type unique identifier, and equal to a new ID. So right here, we're selecting out the new ID. Here it gets a new one every single time. So now we'll start with a GUID string and fill a unique identifier data type variable. So first here we have a GUID string character length of 36 equal to a GUID. And then we also declare a variable that's a unique identifier. And we use the convert the string to unique identifier data type when filling the GUID unique identifier variable. You can see it passes right on through. So as an example of turning a string into a GUID data type. Another gotcha is if you have a string that's longer than 36 characters and you convert it to a GUID, what it's going to do is it will chop off everything that comes after that 36 mark. You can see here it just contained the whole string, or chopped it down to that 36 characters. All right, auto-generating a GUID into a table. Declaring a little temp table. The first column is the auto GUID unique identifier with the default of new ID, and then just a second column that we're going to insert 1, 2, 3, 4 into, and then we'll run a select, which will return the results. So you can see here that it generated a unique GUID for each row that was created in the table. We run it again, another set of unique IDs, another set, just over and over again. Okay, and here we can look at sequential ID. It's the same setup as before, except the default is new sequential ID instead of new ID. So see this first column here, it increments. The first 3 characters increases: CEC, CFC, D0C, D1C, D2C. And you can, as I mentioned in the slides, you can only have new sequential ID the default. So we'll say new ID here. We know that works. We looked at that earlier. Try select new sequential ID. We get the error message saying that it's a built-in function that can only be used in a default expression for the column type unique identifier.
I think that would be a lot better for a cluster index.
So the comment was that would be a lot better for a clustered index than just a regular new ID. And while that would help clustering, it's the GUID data type is 4 times as large as an int. So you're bloating your index out with that. Lookups are slower on that, so that's a negative there. We'll cover this later. And then joins are also slower. So while it might be a little bit faster on inserts, it still is not the best thing to use. Okay, comparison and non-comparison operators. I'll declare a GUID with all A's, a GUID with all B's, and we'll see is the GUID with all A's less than the one with all B's, and we see that it is. So it treats it like a string there. And then we'll do the not equals comparison, and we get the results back. So flip it over to, does the GUID with all C's equal the GUID with all D's, and then it doesn't return anything, so that's not true. Okay, you can use it with the like excuse me, operator. So we declare one, unique identifier with no E's, and then another unique identifier where I flipped one of the characters to an E, and run both of them. The first one will return an E was found if it found an E in the no E GUID. Of course, that's not true, so no results were returned. Ran the same statement, but searching through the has an E GUID variable, which is right there, and one was found. So it does search through the string, kind of like a text string. So let's try arithmetic. We do. The GUIDs are actually stored in the database as a number. So let's try some math. We've got AA, and the last character is a 1, and the last character is a 2 on the second GUID. And let's see if we add 1 onto that first GUID, if it equals the second one. And we get an error saying that unique identifier is incompatible with int. So, like I mentioned earlier, you can't perform arithmetic functions on GUIDs. Let's look at the order by. Gotcha. Ordering by that last set. You can see here in the last set that we get 1, 2, 7, 2AE, 6, 3F, 7, 9, B, 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 D, D. So even though you can search through the GUID like a string, it won't sort the GUIDs like strings. It sorts by the last set. So that's just one thing to keep in mind if you ever think that ordering by a GUID is a good idea. So advantages of using unique identifiers. If you set up your database and say you have an integer identity in multiple tables, and you're trying to bring those tables from multiple sites together, you're going to get clashes on those identities. So some GUIDs are a way you could have identities in multiple environments. They're never going to clash when you bring them together. You have to be wise with how you structure it, because while it helps you with the data merging and replication, it doesn't help with performance. You can also generate GUIDs offline on the client side if you want to. So when you bring all that data together from multiple clients into a database, you can kind of keep track and not have identities clash. Disadvantages: it's 4 times larger than an int, as I mentioned, which means larger indexes, which means slower indexes. It's also going to cause page splits. So there's only so much memory that you can allocate to each page. So when you insert a GUID and you insert it somewhere, it's going to bump out some data from a memory page, which means it has to go find another page to move that memory to. Now you've got data spread across multiple pages. And it also leads to fragmentation, because it has to go find a new page somewhere. That means it's on multiple locations on disk and kind of all over the place. The index will be out of order. It has the slowest join performance out of anything that you join on, any identity style field that you join on. It has the slowest insert and update performance, and it also has the slowest sorting performance. If you include a GUID in your index, especially for primary keys or clustering, when you remove a GUID or insert a GUID for primary keys, it has to go check through all those primary keys, which aren't fast to sort through, and then it's going to add another one somewhere in the middle of the line and bump out a whole bunch of other GUIDs, force them down the chain. Having it as a primary key is going to, which will mean it's probably a column that you're going to be joining on. Since it has the slowest performance for joins, you're going to have performance issues there. And clustering, physical layout of the data on the disk. If you're clustering data on a GUID, since GUIDs are random by nature, when you add a new one, that could be in the middle, at the end. It's probably going to cause your index to be instantly fragmented as soon as you pull a GUID out of there or put some more in. It's not a good column to cluster on. So advantages and disadvantages of using them. Advantages are really just for identifying data from multiple sources. However, there's a lot of disadvantages for using them around performance and data size. So you kind of only want to use them when you really have to use them, and use them in a way that you're not building your query architecture around them, given the performance disadvantages it has. So overview, we went over the size of them, what they are, how they're made, what you can do with them, what you can't. Yeah, feel free to look at the slides on my site.